Welcome. Now we'll discuss nuclear power plant. First is introduction. Nuclear power plant is one of the major energy generation unit in the world. In India, the nuclear power plant installation is 6.7 gigawatt, which is about 2% of total installed capacity of India. The total installed capacity in India of power generation is 380 gigawatt, and nuclear share is only 2%, and there is huge chance to increase the nuclear power plant capacity in India and abroad. In uh, some countries like France, most of the power is generated by using nuclear power plants. Nuclear Power Plant Corporation in India is the agency which is monitoring the nuclear power plant installation and operation. Now we'll discuss theory about the nuclear energy. First is structure of the atom. Atom is composed of proton, neutrons and electrons. All matters are made up of atoms. An atom consisting of proton, neutron and electron. Proton and neutron together form a positive charged nucleus of the atom, so also called as a nucleus. Protons are positive charge and neutrons are neutrals, and electrons, which are orbiting around the nucleus, are a negative charge, and the proton positive charge is same as negative charge of electron. And we have already discussed neutrons are neutrals. Number of protons present in the element is called as atomic number, and the sum of protons and neutrons in atom is called as mass number. And typically the presentation of element is like this: x z atomic number and a that mass number. Or in this way we can present the elements in which z is the atomic number and a is the mass number. Typically radius of nucleus is 10 raised to minus 16 meter, and radius of atom is 10 raised to minus 11 meter. This is the typical helium atom, in which there are two proton and two neutron which form a nucleus at the center, and around the nucleus we have electrons which are orbiting in orbits, and number of electrons are equal to number of protons, and electrons are negatively charged, protons are positive charged, but the charges on proton and electrons are equal. And in this atom there are two proton, so this is the atomic number 2, and 4 proton and neutron, so this is the mass number. So helium is represent in this way, and in all atom typical mass of proton mp equal to 1.0072.77 mm, which is equal to 1.6 3 into 10 raised to minus 27 kg, and mass of electron Me is 0.000548 AMU, equal to 9.109 into 10 raised to minus 31 kg, and mass of neutron Mn equal to 1.008665 AMU, which is 1.674 into 10 raised to minus 27 kg, where AMU is atomic mass unit. And typically elements hydrogen, deuterium, and helium are represented in this way. And we can see that in first two case, the atomic number is 1, hydrogen and deuterium, but mass numbers are different. Okay. In hydrogen, there is no neutron. Okay, there is only proton. So we have mass number is also 1. But in first two, atomic number is same. So elements having atomic number same and different mass number are called as isotope. So hydrogen and deuterium, which is also called as heavy water, is isotope of each other. So isotopes, elements of same number of protons, means same atomic number. And example is that hydrogen and deuterium. So we know chemical reactions when carbon burns form a carbon dioxide and release heat energy. Another reaction is when the hydrogen, okay, combine with oxygen, means burn in presence of oxygen, then water is formed H2O, and this is the helium, deuterium. When deuterium burn in presence of water, it form a heavy water due to O. So these are the chemical reactions. So in chemical reactions, the elements combine together and form another product. But the the atom in chemical reaction does not change its composition. Atom remains as it is in chemical reactions. But in nuclear reaction, the atom changes its structure. In nuclear reaction, the fission or fusion takes place. Its atom will disintegrate or combine to become a large or small. This is the difference between chemical and nuclear reaction. And typically, in most of the nuclear power plant, natural uranium, which is the combination of these three elements, is used as a fuel. So natural uranium is a mixture of uranium 238, uranium 235, and uranium 234. In nuclear fuel, radioactive elements, we have also other particles like positron, which having a positively charged, and these are also called as electron having positive charge. And another particle is neutrino, which is teeny, electrically neutral, and emitted in a emission. Nuclear reaction takes by two way. In one case, the nucleus breaks, and in another case, nucleus of two element combines to release the energy. But the first method is uh, used in a nuclear power plant in which the heavy nucleus is split into smaller, lighter nucleus by bombarding high energy neutrons, and high energy is released, and that reaction is called as nuclear fission. So nuclear fission is the process typically used in nuclear power plant for generating heat. So in nuclear fission, splitting of heavy nucleus by bombarding high energy particles means neutrons. Here, the typical example of fission of uranium nucleus is shown. So we have uranium nucleus, and this is neutron of high energy uh, bombarding on nucleus, and this nucleus breaks into two nuclei. One is Johnian nucleus and another is protonium nucleus, and also two neutrons are produced which are used for further nuclear reaction, and heat energy is released, and this is the nuclear reaction. So we have uranium 235 plus a neutron gives the xenon 140 and strontium 94, and two neutrons plus heat energy release. Okay, so this is the nuclear fission reaction which is typically used in power plant. And the energy release in a nuclear fission is given by this equation: energy release equal to delta m into c square, where delta m is a mass defect and c square is the speed of light square. So what is mass defect? Mass defect is the difference between the sum of mass of the components of atom, neutron, proton, electron, and actual mass of atom. Means there is a difference between the actual mass of atom and sum of mass of proton, neutron, electron. That difference is called as mass defect, and the energy released in fission of atom is given by delta E equal to delta m c square, delta m mass defect and c speed of light. Another nuclear reaction is a nuclear fusion in which the lighter nuclei combines and form a heavier and stable nuclei, and the energy is released which is given by delta m into c square. And to carry out this process, very high temperature is required, which is 10 raised to 9 degrees Celsius, which is practically difficult. So nowadays, this nuclear fusion process is not used in nuclear power plants. Only nuclear fission is used, in which the heavier nucleus is break by bombarding high energy neutron on it. In nuclear power plant, electron is bombarded on a heavy nucleus, and heavy nucleus breaks by fusion process and produces lighter nucleus, and release huge energy which is used to generate steam, and it also generate extra neutrons. These extra neutrons produced in a fusion process again bombard on next nucleus, and fission of next nucleus takes place. So number of neutrons go on increasing. So to continue nuclear reaction in control condition, cadmium type control rods are provided, which absorb the extra neutron produced and keep the minimum neutrons or required neutrons in the process to release the constant heat in nuclear power plant. So nuclear reaction in a reactor is controlled by cadmium control rods, which absorb the uh, extra neutrons produced. So nuclear reactor is the critical component of nuclear power plants. Now we'll discuss the components of nuclear reactors. Nuclear reactor consisting of reactor vessel, then fuel rod, moderator, control rod, reflector, coolant, shielding. So this is typical picture of nuclear reactor, which consisting of this vessel, which is made up of low carbon steel, and inside it is covered by highly polished stainless steel sheet. Then it consisting of a fuel rod, which may be natural uranium or in metal breeder thorium and uranium. Then it consisting of control rod, which are uh, made up of cadmium or beryllium, and this control rod absorb the neutrons and control the nuclear reaction in a nuclear reactor. Then it consisting of coolant, which enter in the reactor, absorb the heat generated in nuclear reaction, and use the reactor, and it enter into heat exchanger where it generate steam. So coolant is used to absorb heat, and the coolant used in nuclear reactors are the light water, heavy water, then gas and liquid metals are also used as a coolant. Then we have a moderator, which slow down the neutron speed, and uh, it guide the neutron to bombard on nucleus. So moderators typically use are graphite, then what light water, heavy waters are also used as a moderator. Then this reactor vessel is covered by concrete sheet to for a safety purpose, such that radiation will not escape to the atmosphere. So this is the typical arrangement of nuclear reactor used in power plant. Now we'll discuss classification of reactors based on neutron energy. The reactors are classified as a low neutron energy, medium neutron energy, and high neutron energy reactors. Then second type is based on type of fuel use. Natural uranium, enriched uranium are the type according to fuel use in the reactor. Then next type is based on coolant use. So coolant use are light water, heavy water, graphite, liquid metals. So according to that, we have type of reactors. Fourth type is according to moderator, which is used to slow down the neutron. And moderators use are light water, heavy water, graphite. Then based on type of core used in a reactor, that is homogeneous and heterogeneous reactor. Now we'll discuss The type of nuclear power plant. These are the types of nuclear power plant. First is pressurized water reactor power plant, then boiling water reactor power plant, gas cooled reactor, Kandu reactor, sodium graphite reactor, OMCR, liquid metal fast breeder reactor, conceptual fusion reactor. So these are different nuclear reactor. Now we'll discuss few nuclear power reactors used in nuclear power plants. So first is pressurized water reactor power plant. So this is the typical picture of pressurized water reactor, which consisting of your nuclear reactor, and the fuel used in this reactor is enriched uranium, and coolant and moderator is used as a heavy water, that is D2O, and this reactor is working at a pressure of 130 to 150 bar, and here is pressurizer provided in this uh, reactor. When the pressure decreases, these electrical heaters uh, create the steam, and that steam maintain the pressure in the reactor and also maintain high pressure. That's why this reactor is called as pressurized water reactor. Now the heat generated is absorbed by the heavy water, and that heavy water flows to this heat exchanger, where the heat of heavy water is transferred to the steam or water, which converted into steam, and that steam is passed into steam turbine, where it expand and develop work, and with the help of that generator is operated and electricity is produced, and the exhaust steam goes to condenser, where it condenses and then again pump into heat exchanger with the help of this feed pump, and heavy water leaving the heat exchanger is again pumped into nuclear reactor with the help of coolant pump. So pressurized heavy water reactor consisting of nuclear reactor, pressurized vessel, then heat exchanger, coolant pump, and Rankine cycle is coupled to generate power. Pressurized water reactor, primary coolant is pumped under a high pressure to reactor core, where it gets heated. Heating water is done by nuclear fission. Heated water flows to steam generator, where it transfers its thermal energy to secondary system. The steam generated in secondary system flows to turbine, which turns uh, the electric generator. Next is boiling water reactor. The boiling water reactor is of light water nuclear reactor. It is used for generation of electrical power. It is the second most common type of electricity generating nuclear reactor after the PWR. It uses enriched uranium as a fuel and water used both as a coolant and moderator, and its work at a pressure of 70 bar and uses saturated steam around at 285 degrees Celsius. So this is the typical arrangement of boiling water reactor. So this is a reactor which consisting of fuel rod, control rod, and direct the light water enter into the reactor, where it get boiled due to heat generated by nuclear reaction, and steam generated in nuclear reactor is directly passed into the steam turbine for generation of power, as the light water, which is used as a coolant, moderator, and also working fluid for the Rankine cycle, and the Steam is directly generated in the reactor from the light water. So the name of this reactor is boiling water reactor. And the typical components of the boiling water reactor are reactor, pressure vessel, nuclear fuel element, control rods, turbine, generator, condenser, pump. So these elements are in this power plant, boiling water reactor power plant. What are the advantages of this boiling water reactor? Reactor operate at low pressure. Then pressure vessel is subjected to less irradiation compared to pressure water reactor. Lower temperature of nuclear fuel, lower risk to rupture causing loss of coolant. A boiling water reactor may be designed to operate using natural circulation, so avoiding pumps for recirculation. Now next reactor is gas cooled reactor. In this case, the gas is used as a coolant, and the first gas reactor was developed by UK, and in that reactor CO2 was used as a coolant instead of water, and graphite as a moderator. So the that gas reactor uh, was known by gas cooled graphite moderated reactor, and this reactor, gas cooled graphite moderated reactor, that is GCGM, uses natural uranium as a fuel, and the pressure is about 7 bar and temperature is 336 degrees Celsius. Another gas cooled reactor was developed by USA using helium as a coolant and graphite as a moderator, and it works at high temperature of 700 to 800 degrees Celsius and 30 bar. So this gas cooled reactor is called as high temperature gas cooled reactor, and the typical efficiency of high gas temperature cooled reactor is 40%. And these are the components of gas cooled reactor. We have here is reactor, which consisting of nuclear fuel, then coolant as a gas, CO2 or helium. Then we have moderator of graphite, and this gas is heated by nuclear reaction, and that gas is passed into heat exchanger, where it exchange it heat to water, and steam is generated from the water, which is used in Rankine cycle to produce power. And again, this gas is pumped into reactor. So this is typical gas cooled reactor. Now next reactor is Canadian deuterium uh, reactor, which uses pressurized heavy water DTO as a moderator and primary coolant, and fuel use is natural uranium. And this reactor is called as Candu reactor because it was developed and designed by Canadian. So the name is Canadian deuterium uranium reactor, and it works on the heavy water. So this is also called as Canadian deuterium uranium pressurized heavy water, and natural uranium oxide fuel in the form of small cylinder pellets are used as a fuel, and the typical size of the fuel is placed in the tubes of zirconium having size 0.5 centimeter long and 1.3 centimeter diameter, and these bundles of tubes are placed in one pressurized vessel cylinder called as a calendaria, and the active core of a condo reactor is 6-meter high and 7 to 8-meter in diameter. In a primary circuit, means in this circuit, the heavy water enter into the reactor, and due to nuclear reaction, this heavy water is heated, and the deuterium typically enter at 110 bar into calandria and 260 degrees Celsius. And when it flows through the calandria, it get heated and it leaves the calandria at 370 degrees Celsius and 110 bar and enter into this steam generator, where the heat of heavy water is transferred to water and steam is generated. That steam is used in Rankine cycle, and the control rod made up of cadmium are used in the calandria to control the nuclear reaction. Next is the liquid metal reactor, that is sodium graphite reactor, which uses sodium graphite liquid sodium as a coolant and graphite as a moderator, and this work at very high temperature at 50 degrees Celsius at 7 bar. It consisting of two circuit. In a first circuit, which consisting of nuclear reactor, in which the liquid sodium is flowing. When liquid sodium comes in contact with nuclear reactor, it is get heated, and high temperature liquid sodium enter into heat exchanger when one where it transfer the heat to the uh, potassium liquid, and then again this sodium potassium liquid transfer the heat to the water, and water and converted into steam, which is further used in Rankine cycle for generating power. And here two circuits are used: primary heat exchanger and secondary heat exchanger. This is because liquid sodium is very corrosive in nature, and that's why two heat exchangers are used in liquid sodium graphite reactor. So this is about the nuclear power plants, in which we have discussed the structure of atom, then the types of nuclear processes, that is fusion, fission process, and fission process is used in nuclear power plants. We have discussed the elements of nuclear reactors and their use, types of nuclear reactors, and then we have discussed the different nuclear power plants. Thank you for listening this video.